In this lesson, we are going to learn about classes. Object-oriented programming, which C# is a part of, is a style of programming that focuses on using objects to design and build applications. In order to create an object, you need to have a class first. A class is a blueprint or a template that is used to create new instances called objects. An example of a class is the computer class. In this example, computer is the class. An object of the computer class might be Hewlett-Packard. Another object could be Toshiba, Dell, or possibly Acer. And another example of a class could be the auto class. In the auto class, you could have objects like Toyota, Nissan, and Dodge. To create a class, you need the following things: an access modifier or access specifier. Access modifiers allow a particular group to use the class. For beginners' purposes, we will use the public and private access modifiers. Just so you know, there are other types of accessors that may be used. The second thing you will need to create a class is the class keyword. And the third thing you will need is the class name, which you will use to create a new instance of your class called an object. And lastly, you will need a code block, which is enclosed by a pair of curly braces. In our example of a computer, public would be the access modifier. We would follow that with the class keyword right next to it. Then we would have the class name, which is computer, which is to the right of it. We then would have our code block, which you see right underneath it. And within the code block, we are defining our computer class. We are defining both the manufacturer and the model of the computer class. Before you can use a class, you need to instantiate it. Instantiating a class means you create a new instance of the class called an object. To instantiate a class, you use the new operator. Once you have created an object, you can access the class using the dot notation. So here in the bottom, we have an example of instantiation. And we have our computer class, so we write that name out. Next to it, we write the name of the object, which is going to be my computer. Object is also known as a new instance of the class, in this case, the computer class. And then we use the new operator, and then we write the original class name again. Before we get into our coding exercise, I want to talk to you about methods. A method is a code block that has a name. An example of a method is when we first create a project and our screen displays static void main. Main is the name of the method. Within the code block of a method is a series of statements that perform a task. To use a method, you need to define and call the method. To define a method, you need to have an access specifier. An access specifier indicates who can call the method. For example, you can either make it public or you can make it private. Another thing you will need is a return type. A method can return a value. Return type specifies the data type of the value to be returned. If no value is returned, the return type is void. You also need a name for your method, and this refers to the name of the code blocks we'll use to run the method. For example, the name manufacturer. Lastly, you need parameters. Parameters are used to pass and receive data from a method. Parameters are enclosed within parentheses. Some methods do not contain parameters. If you are not passing in parameters, you must include a set of empty parentheses after the method name. I want us to now practice what we have learned. I'm going to create a new project. And I'm going to name my new project Object OO. I'm going to add a class so we get used to working with multiple classes rather than a single class at a time. To add a class, you select the Object OO project, not the solution on top of it. So this is the project, and I'm going to right click on it, and then you're going to go down to where it says Add, and then on this screen or this window you're going to go down and you're going to choose Class. Left click on that, and I'm going to name this class Computer. So let me delete that and Computer. And then you just click Add, and we have now added the computer class. It tells us right here. Here's our class Computer. I'm going to place the requirements for a method here to make sure we code this correctly. So let me just paste it here, and there we go. And now I'm going to type my code. When you look at this code, you see that I started with the access specifier public. Then I added my return type, which is void, because I will not be returning a value. Remember, void does not return a value. Next, I type the name of my method, which is manufacturer. Then I have a set of empty parentheses because I'm not passing in any parameters. Lastly, I have my code block right here, and it includes my statement. Now I want to be able to call my manufacturer method from my main method. So I'm going to go to program.cs. Underneath my main method right here, I'm going to start typing. Let's take a look at my first line of code. On this line, I instantiated the computer class. I did this by typing computer. The reason I typed computer is because the manufacturer method lives inside the computer class I want to access. So if we go back to our computer window here, computer.cs, you will see the manufacturer method right here lives inside of the computer class, which is right here. And then if I go back to program.cs, you see that on the first line, I assigned a variable named myComputer to the computer class. Remember from our previous lessons that before you declare a variable, you need to state what type of variable it will be. The computer class is the type, and myComputer is the name of the variable. I then assign myComputer to a new instance of the computer class by using the new keyword and typing the computer class after it. So by instantiating the computer class, I created a new object. Now my variable, which is my computer, has the computer class inside of it. This will allow me to use the manufacturer method. On the next line, I type my variable, my computer, and when I use the dot syntax, I got a drop down that included the manufacturer method, which I chose. And since this is a method, I included my parentheses here at the end, and I ended my statement with a semicolon. Lastly, I included my console.read line here at the bottom to keep the application from closing. Now I'm going to run this program. As you can see, it printed out, this is a Toshiba computer. So we were able to successfully call the manufacturer method. I want to now break down this program with you. I'm going to put a breakpoint next to computer, my computer equals new computer. Then I'm going to click on start to start debugging. When I pull up my console window, you can see that it is empty. Because of my breakpoint, my code has stopped executing on this line. If you look at my locals window, you see that the my computer variable is currently null. The reason it is currently null is because it hasn't been assigned yet. So I'm going to click on step over. Now you see that my computer has a value of computer right here. So this line shows we have created a new computer object and stored it in the my computer variable. Now I'm going to call the manufacturer method. To do this, I'm going to click on step into rather than step over. Step into shows me what this program does when I call the manufacturer method. So let me just bring this down here so we can see all our code. As you can see by the highlighted curly brace, when we click step into a couple of times, it's going to execute the statement in the code block. Now let me pull up my console window so you can see that. And there you have it. This is a Toshiba computer has printed to the console window. So this statement here executed. That's what step into showed us. When I click on step into again, I am back at the my computer .manufacturer line of code. And if I click on step into again, I go to the next line and continue running my code. So just to be clear, when you call a method in .NET, code execution stops immediately, such as when I called the manufacturer method. Then you go into your method and the code within the method runs, like when the code in the manufacturer method ran and printed out, this is a Toshiba computer, to my console window. And once the code in the method runs, you go back to your line of code where you called your method. Your program then goes into the next line of code and continues executing. In this video, we discussed classes. I told you that a class is a blueprint or a template that is used to create new instances called objects. And in order to create a class, you need to have 4 things: a modifier, such as public or private, the class keyword, a class name like the computer class we used, and a code block. You also learned about a method. I told you that a method is a block of code that has a name. And in order to define a method, you need an access specifier or modifier, such as public or private. You also need a return type, and you need a method name like the manufacturer method we used. And lastly, you need parameters. And remember, if you do not have any parameter to pass in, you need to include a set of empty parentheses. You also practice breaking down code. You learn how to use step into to go inside your code and see how your application executes it. In object-oriented programming, there are 3 main concepts. The first concept we are going to discuss is inheritance. Inheritance allows you to create classes that inherit certain aspects from another class. This allows you to reuse code and extend and modify the behavior that is defined in other classes. Let's create a new project and give it the name Inheritance. And let's add a class. And give it the name Auto. Here we have our Auto class, which is our base class, and we are going to type some code that will be available to other classes. So let's think about things automobiles have in common. Automobiles have a make, so I'm going to create a public string called make. And you typically don't want to make your fields public, but in this case we will, because we want our other classes, which are known as derived classes, to be able to access these fields. Automobiles also have a model, so let's create a public string for model. And automobiles have a year, so I'm going to create a public string for year. I want my derived classes to be able to print the make, model, and year of their vehicles, so I'm going to create a print method. So I'm going to type public void, because I'm not going to return a value, and I'm going to type print. Then I'm going to include my two curly braces, and I'm going to type out console.writeLine and my quotes make colon plus make. And then I'm going to include another console.writeLine, this time for the model. And I'm going to type model. Let me include a space there. Plus model. And let me include a space here as well. And then I'm going to type my final console.writeLine, and that's for the year. Oops, just type that there. Now I'm going to add another class. And I'm going to give it the name truck. My truck class is a derived class, and I want to be able to use the fields and methods of the auto class, which is my base class. In order to gain access to my auto class, I need to include a colon after my truck class. Then I have to write the name of my base class, which is auto. When I think about a truck, two things stand out for me. One thing is its torque. So I'm going to create a public field. So let me type public. I'm going to make it of type int. And I'm going to name it torque. The other thing about a truck that stands out to me is its towing capacity. So I'm going to create a second public field. It's also going to be of type int, and I'm going to name it towing capacity. Next, I'm going to create a method that will return the torque. So I'm going to type public int and give it the name getTorque. And I'm going to include my curly braces. And in my code block, I'm going to return torque. Then I'm going to create a second method for my engine. So I'm going to type public. Then I'm going to type void because I do not want to return a value. And I'm going to name it engine. Let me include my curly braces. I want my engine method to print something out, so I'm going to type console.writeLine, and in the parentheses I'm going to type this is a powerful engine. Now I'm going to add another class, and I'm going to give it the name car. And when I think about a car, I think about its speed, so I'm going to create a speed field. So I'm going to type public int speed. Another thing that comes to mind when I think about a car is its transmission. So I'm going to add a transmission field. So I'm going to type public. This time I'm going to use the string type. And I'm going to name it transmission. And I'm going to add a method called acceleration. So I'm going to type public again, void, because I will not be returning a value, and acceleration. And I'm going to print out console.writeLine, or rather I'm going to add console.writeLine so I could print something to the console window. I want to print my car accelerates at 0 to 60 in 5.8 seconds. And when I look at this derived class, I notice something. I notice that I forgot to add the colon and auto after my car class. Now I'm going to go to program.ts. The first thing I want to do is instantiate my truck class. So I'm going to type truck, my truck equals new truck. Then I'm going to assign some values to my truck. So I'm going to type my truck dot, and when I type dot, notice all of my options. Within my options, you can see that I can choose the make, model, and the year. I am able to do that because of inheritance. So let me assign some values to my fields. So I'm going to start with make. I'm going to choose that option, and I'm going to assign it a value of Chevy. Then I'm going to go down. I'm going to choose my truck again. This time I want to choose the model field, and I'm going to assign it a value of Silverado. Then I go down again, my truck. This time I'm going to select the year field and assign it a value of, oops, this is not a string, so I need to get those quotes out of there. But I'm going to assign it a value of 2015. Then I'm going to continue, and I'm going to type. And before I continue with my truck, I notice I have a red squiggly line here underneath 2015, it says cannot implicitly convert type int to string. So what happened here is actually in my auto class, I have the year listed as a string, and that's incorrect. So I have to make the change here. So make sure if you're typing along with me, you change string to int, okay? Because an integer is a whole number. It's not going to be a string. So now when I go back to program.cs, the red squiggly line has disappeared. So let me continue typing, and I'm going to type my truck. This time I'm going to choose the torque, and I'm going to assign it a value of 925. And I'm going to continue my truck. This time I'm going to work with towing capacity, and I'm going to assign that a value of 21,000. One important thing to know is that if you put a comma here, like you normally would write 21,000, you're actually going to get an error, okay? And if you put your mouse over it, it says only assignment, call, increment, decrement, and new object expressions can be used as a statement. Basically, the problem is that you put that comma, okay? C# doesn't like commas, so you cannot include a comma when you're writing a number like this, like 21,000, okay? So just keep that in mind as you code in the future. I also want to use the print method from my auto class so I can print out the make, model, and year of my truck. So I'm going to add my truck, and I'm going to choose the print method, which appears in my auto class. And I want to print out the engine method from my truck class, so I'm going to type my truck, and then I'm going to search for engine. Here we go. And I'm going to include my semicolon here at the end. Then I'm going to include a console.writeLine for my torque. And I need to include my truck and torque here at the end so I can actually print out my torque. And I'm also going to include a console.writeLine for my towing capacity, okay? So let me just go to console.writeLine. And include my truck and choose towing capacity. And let me include my console.readLine here at the end so that my program stays open. And let me run this program now. If you look at my console window, you see that I printed out the make, model, and year of my truck. And you know they came from my base class auto. Then you see that I printed out the engine method for my truck class. That's why it says this is a powerful engine right here. Then you see that I used a console.writeLine, which I typed into program.cs to print out the torque and the towing capacity from my truck class. So let me close out of this, and now I want to access my car class. So the first thing I need to do is instantiate my car class. So I'm going to type car, my car equals new car. Then I'm going to assign it a make. So I'm going to type my car. Oops. My car. Dot, and let me find the make. And I'm going to assign it a value of Nissan. Then I'm going to continue. This time I'm going to type my car, and I'm going to look for the model, and I'm going to assign it a value of Altima. then my car, and this time what I want to do is access the year and assign it a value of 2016. I want to print the make, model, and year, so I need to assign it the print method from my auto class. So I'm going to type right down here, my car dot print. I'm looking for the print method. Here it goes. And then include my semicolon. Next, I'm going to assign the speed from my car class a value of 90. So I'm going to type my car, then speed, and I'm going to make it equal to 90. And the transmission is going to be manual, so I'm going to type my car dot transmission, and it's going to be equal to manual. And I'm going to include a couple of console.write lines to print out my speed and transmission. And one more console.write line. And there we go. And let me run this program. And here you see I printed out the make, model, and year of my car class. And like with the truck class, we were able to borrow this code from the auto class. We just assigned the make, model, and year a value. And I used the two console.write lines that I typed into program.cs to print out both my speed and transmission type. In this video, you learned about inheritance. You learned that inheritance allows you to reuse code. During this lesson, you reuse the code from your base class auto to print out the make, model, and year of both your truck and auto classes. Without inheritance, you would have had to type or copy and paste the make, model, and year into both the truck and car classes. So by reusing or inheriting code, you were able to minimize the code you needed for your application. Also, remember that your base class makes code available to your other classes that are known as derived classes. And another thing I want you to be aware of is that the base class is sometimes referred to as the parent class, and derived classes are sometimes called child classes. This lesson will cover encapsulation. Encapsulation is the second of three main concepts related to object-oriented programming. Encapsulation allows you to hide data and behavior from outside classes. This enables you to protect the integrity of your data. When working with encapsulation, you need to decide on the access level you want to grant to outside code. You make this decision by using access modifiers. Access modifiers allow you to grant full access, partial access, or no access to external code. The access modifiers we will be working with are public and private, but I want you to be aware that there are three other access modifiers: protected, internal, and protected internal. Let's get into an example to demonstrate encapsulation. I'm going to go to my truck class and change my torque field to private. So let me change that. Then I'm going to go to my program class and notice that underneath torque, I have that dreaded red squiggly line. As I hover over it, it says truck.torque is inaccessible due to its protection level. If you recall, we got a similar message in a previous lesson. And as you might recall, the reason we are getting this error message is because torque has an access modifier set to private. You cannot access private code from another class. You can only access private code from the class it is in. The reason we make code private is because we do not want anyone else using an external class to change our code. If you wanted to allow someone to use torque from another class, you would give them access to the getTorque method, which is set to an access modifier of public. So when someone else outside this class calls the getTorque method, they will not be able to see the code inside of it. The getTorque method encapsulates the code or hides the code from whoever is accessing this method from another class. To give someone access to torque, you would go to program.ts and you would add my truck, and we're going to look for the getTorque method. And here we have our getTorque method. And before I run my program, I need to make sure to comment out this line of code here. So let's comment that out. And also we have a red squiggly line right here as well. That's because our torque field is private. So instead of commenting this code out, I'm going to modify it to print getTorque. So I'm simply going to add get here. And this changes it to getTorque. And I have to remember to include my parentheses right here. So now you notice that the red squiggly line is gone. And what I'm going to do is I'm going to print out my getTorque method, okay? So let's run this and see how it works. On my console window, you can see that I printed out my torque is 0. So I was able to use the getTorque method. In case you're wondering why I get 0 for my torque, that's because I didn't assign the torque field a number. When a number is not assigned to a private integer, it prints out the default value, which is 0. So let me close this out. If you want, you can assign a value to torque. So I'm going to assign this a value of 8. And if you run the program again, you see now that it says my torque is 8. Now I want to briefly go over some terminology that is used to describe code in C#. The first thing I want to explain to you is a private member. When you hear the word private member, it refers to the name of your private variables. In this truck class, the private member is torque. Torque is a member of this class, not the other classes. And since torque is a private member of the truck class, it can be accessed by member methods. The member methods in the truck class are public int getTorque and public void engine. If you click on the car class, the member method is public void acceleration. In the auto class, the member method is public void print. We also have something called member variables. In the truck class, the member variables are torque and towing capacity. So torque is both a private member and a member variable. If you look at the car class, your member variables are speed and transmission. In the auto class, your member variables are make, model, and year. The last bit of terminology I want to cover with you is member function. Functions are statements that perform a specific task. In the auto class, the member function is print. Print is going to perform the task of printing the make, model, and year. In the truck class, the member functions are get torque and engine. And in the car class, the member function is acceleration. During this lesson, we discussed encapsulation. I told you that encapsulation helps you hide data and behavior from outside classes. This enables you to protect your code from others who may want to make changes to your code. In our example, I showed you how to allow the use of your private members by containing the private member within a public method. You saw that when we allowed access to the getTorque method that encapsulated torque. We then printed out the torque to the console window. And lastly, we reviewed some terminology that is commonly used in C#. I reviewed with you private members, member methods, member variables, and member functions. In this lesson, we are going to discuss polymorphism. Polymorphism is the third major concept of object-oriented programming. Remember, the other two are inheritance and encapsulation. Polymorphism allows us to create a class and include members in the class that will act differently. Believe it or not, you have already worked with polymorphism. I just never told you that you were working with polymorphism. This lesson will serve as a review, and it will clarify the concept of polymorphism. What I want to do now is I want to go back to our inheritance code, and I want to make some changes to the code that will set up our coding example. I'm going to comment out all this code right here. So let me click on comment out. Then I'm going to go to my auto class and I'm going to comment out my fields. Next, I'm going to go to my truck class and I'm going to comment out all my fields and methods. And then in my car class, I'm going to comment out my fields and my method. Now I want to add some code. I'm going to add a print method to my car class. So I'm going to type public void print. Then I'm going to go down and add my code block, and I'm going to add console dot writeLine. This is my car class. And I'm also going to add a print method to my truck class. I'm going to type public void print, then my curly braces, and console dot writeLine. This is my truck class. In this example, we have a truck and car class that inherit from an auto base class. We also have three different print methods. The truck print method will print out, this is my truck class. The car class has a print method that will print out, this is my car class. And the auto class has a print method, and I'm actually going to adjust this, okay? I'm going to get rid of this. So I only want to print out the words make, model, and year, along with a colon right after them. So let me get this out. Now I'm going to go back to my program class. What I'm going to do now is create an instance of the auto class, and this instance will be an array of the base class auto. Now this is something new. In order to create an instance of our base class and to make this instance an array of the base class, I'm going to first type auto. So let me just get down here, auto. Then I'm going to include a set of brackets that indicate an array. Then I'm going to give the new instance the name A. And I'm going to include the equal sign, then the new operator, then auto, and immediately after auto, I'm going to include a set of brackets. Within the set of brackets, I'm going to include the number 3 because I want to include 3 elements in my array. And then I'm going to add a semicolon at the end. Now I'm going to move this up a little bit so we could view things a lot easier or better. And what I'm going to do is I'm going to create an instance of each of my 3 classes. The first class instance I'm going to create is for the truck class. So on the next line, I'm going to type the name of my object, which is A, and then I'm going to include a set of brackets because this is an array. In the brackets, I'm going to include a 0 because if you recall, the first element in an array is 0. And then I'm going to type equal, followed by the new keyword, and then I'm going to type truck, and then I'm going to include my parentheses and a semicolon at the end. I'm going to do the same thing for the car and auto classes. So to make things easier, I'm going to copy this line of code here. Let me just copy that, and let me just go here, and I'm going to paste it here, and then I'm going to paste it one more time. Let me move the console.read line down, and I'm going to change it so I have an instance of both my car and auto classes. So I'm going to change this 0 to 1 because it's my second element in the array, and I'm going to change truck to car. Then I'm going to go to my third element, and I'm going to change the 0 to 2. And let me change truck to auto. Now I'm going to call the print method of my base class and each of my derived classes. To do this, I'm going to use a for each loop. So I'm going to type for each, then my parentheses, and in the parentheses, I'm going to type the name of my base class, which is auto. Then I'm going to type vehicle because that describes all of my classes. Then I'm going to include the word in, followed by A, which is the name of my object. Next, I'm going to type my curly braces, and I'm going to call my print method. I'm going to type vehicle dot print. Now let's run this program and see what happens. What you see here is that the same print method printed out 3 times. This is the print method that belongs to the base class auto. So how do we get each of our derived classes to print out each of their print methods? We do this by implementing polymorphism. Like I told you earlier, polymorphism allows us to create a class and include members in the class that will act differently. You have already done this before in a slightly different way by using the virtual and override keywords. We are going to make the code in our classes act differently. We are going to make the code in our derived classes override the base class's print method and instead print out their own print methods. So let's go to our auto class and let's include the virtual keyword between public and void. Remember, the virtual keyword lets derived classes know that this method can be overridden. Derived classes don't have to override our base class, but they can if they want to. Next, I'm going to go to my truck class and include the override keyword between public and void because I do want to override the base class's print method. So let me include it here. Now I'm going to go to my car class and include the override keyword there too. Now let's run this project, and as you can see, we were able to print out the truck class's print method, the car class's print method, and the auto class's print method. So we were able to use the for each loop and the virtual and override keywords to print out all of our print methods. What you experience here is polymorphism. Polymorphism is useful when we have a group of objects in an array that need to have their methods printed out. In the last video, you learned about polymorphism. Polymorphism allows you to create a class and include members in the class that will act differently. You learned that by changing the behavior of your code using the virtual and override keywords, you could get the print methods in your base class and the print methods in your derived classes to print at the same time. In this lesson, we will look at another example of polymorphism. In this example, we will print methods without using the virtual and override keywords. In other words, you are going to learn how to print from derived classes without having a base class implementation. So how do you print from only derived classes and not from the base class? You do so by using something called an abstract class. An abstract class is similar to a regular class, except it cannot be instantiated. If you try to instantiate an abstract class, you will get a compile error. Abstract classes are used as base classes, so they can be derived from. In other words, you can create derived classes from an abstract class. Let me show you how to create an abstract class. I'm in my auto class now, and what I'm going to do is I'm going to include the abstract keyword right in front of class. So let me type abstract. So now I have an abstract class. What I want to do now is I want to include an abstract method within my abstract class. An important thing I want you to know is that you are not required to include an abstract method in an abstract class. You can include a regular method, and in this example, we will include both an abstract and a regular method. Now I want to create my abstract method, and the first thing I need to do is I need to delete this virtual keyword. So make sure you delete it because we don't need this. So our method should look like this. And what I'm going to do is I'm going to add the abstract keyword between public and void. And another important thing you need to know is that you cannot define the definition of an abstract method. What this means is that abstract methods do not contain a code block. So I'm going to comment out this code block. Next, I'm going to go to my truck class and add a new print method. So I'm going to go right down here. I'm going to add public override void print. And when I press enter, it automatically set my code within the code block, but this is not what I want. So I'm going to delete this, and I'm going to include console dot writeline this is my truck class. You need to include the override keyword when deriving from an abstract class. Otherwise, you will get an error message. And let me go to my car class and add a print method there too. So I'm going to add public. I'm going to remember to include the override keyword because remember, abstract classes require an override keyword on derived classes, at least on the methods of derived classes, okay? Then I'm going to include void, then print. Then I'm going to delete this here. And within the code block, I'm going to include console dot writeline. This is my car class. Now each of our classes has a print method. We want to call the print method of only the truck and car class. Let's go to program.cs and comment this out right here. And I'm going to change the number of elements to 2. Let's run this program and make sure it works. It looks like we have an error here. In this box here it says there were build errors. Would you like to continue and run the last successful build? I'm going to select no. And when I select no, I have this error list that populates at the bottom. And it says something about a semicolon expected. Looks like in my auto.cs class. So what I'm going to do is I'm going to close out of this and I'm going to go to auto.cs. And when I look over here at my abstract method, I see that I have that little red squiggly line, and it looks like I need to include a semicolon here at the end. So when I do that, the red squiggly line is gone. Now this looks good here, so I'm going to go back to program.cs. Everything here looks good. I'm going to click on start and run this program. And there you go. We were able to metamorphically call the print methods for both the truck and car classes. The abstract print method in the auto class did not print out. How about if you wanted to print the methods in your abstract class? How would you go about that? What you would do is inherit from the auto class by typing a colon after program followed by auto. So let's type public. Then instead of abstract, I'm going to type override followed by void, then print. Then I'm going to include my curly braces and console dot writeline. This is my first print method in the auto class. So now I've defined my method with this code block. What I'm going to do now is I'm going to go to the auto class and add a method there too. I'm going to add public void, and I'm going to make this print2. Then I'm going to add my code block to define my method, and I'm going to add console dot writeLine. This is my second print method in the auto class. If I click on start, you see that nothing has happened. I'm still printing out the methods from before. And the reason why the two new methods I added, the one I added to the program.cs and the one that I added to auto, haven't printed out is because I haven't instantiated the program class. So let me close out of this, and I'm going to go back to the program class, and I'm going to go to the bottom here, and I'm going to instantiate my program class. So I'm going to type program P equals new program. Then let's call the print and print2 methods. So I'm going to type p.print, and then I'm going to go to the next line and I'm going to type p.print2. Now let's run this program, and you can see both the print and print2 methods on your console screen. There are a few important things you need to know about abstract classes. Abstract classes cannot be sealed. So what does this mean? When a class is declared sealed, it cannot be instantiated. Let me show you what a sealed class looks like. To seal this class, you include the sealed keyword between abstract and void. As soon as I finish typing sealed, you notice I have a red squiggly line underneath print. And when I hover over print, it says auto.print cannot be sealed because it is not an override. So we need to remove the sealed keyword so that the error disappears. The next important thing you need to know about abstract classes is that they cannot contain private abstract methods. Let me show you. So I'm going to change this here from public to private. And you can see that we have an error message, and it says auto.print virtual or abstract members cannot be private. So this will not work. So let me change this back to public. Another thing you need to know about abstract classes is that they cannot contain abstract methods that include the virtual keyword. If I include virtual between abstract and void, you see that once again I get an error. And when I hover over the error, it says the abstract method auto.print cannot be marked virtual. This will also not work, so I'm going to delete the virtual keyword. Lastly, abstract classes cannot contain any static methods. When I include the static keyword between abstract and void, you see that once again I get an error message, and this time the error says a static member auto.print cannot be marked as override, virtual, or abstract. So this will not work either. So let me just get rid of this. In this lesson, you learned about polymorphism via abstract classes. You learned that by using an abstract class, you can call the print methods of your derived classes without having to call the base class's print method. In this lesson, you also worked with abstract classes. You learned that an abstract class cannot be instantiated. You also learned that abstract classes are used as base classes so you can create derived classes from them. I also told you that you are not required to include an abstract method in an abstract class. You also learned that abstract methods cannot be defined. That means they do not contain a code block. Another thing you learned to do in this lesson is how to print methods from your abstract class. You learn to do this by going to your program class and inheriting from the auto base class, then typing your method from the abstract class directly below the program class. You then had to instantiate the program class and you were able to print out the abstract class's methods. And finally, you learned that abstract classes cannot include sealed, private, static, or virtual methods.